And here's another great XKCD comic about the problem of multiple testing, but you should look at that yourself. I don't explain it here, but really look at it. Unfortunately, the story in the comic may be closer to the truth than we would like hope. So many discoveries in empirical sciences, particularly in medical sciences, for example, whether a drug has some positive effect, or in behavioral sciences, are claimed because you run an experiment, and a null hypothesis is that there's maybe no effect, can be rejected with a p-value below 5%. However, even if there is no effect, one finds in 5% of the cases a p-value below 5%. If I test 100 drugs that help against some disease, I would find in 5% of my tests the result that the drug works, even if the drug has no effect for helping against the disease. Now, is this a big problem or not? It's hard to say, but some observers argue that combined with some other factors, this may cause many false discoveries in scientific publications. So there's an article that had a lot of influence with the title "Why Most Published Research Findings Are False." I think most is a very extreme word, but it gives you quite some nice arguments why we may have problems. You can also search for the term replication crisis. So the idea is, are there many results that have been published which we cannot replicate in new experiments? And if you, for example, look at the Wikipedia page, which is linked here, you see some nice background for it. So it has been discussed a lot in psychology and medicine, but we also have examples in other fields, in marketing, in economics, sports science, water resources. Maybe not so much in the hardcore sciences like physics, but it's quite interesting to read. Let me discuss two possible problems. So the one is so-called publication bias. So typically it's easier to publish an article that has some new interesting discovery. So it finds some interesting effect. An article that does not find an effect is not so interesting to read, and also not so interesting to publish. Because, there are many non-effects. So it's nicer to have some effect. But now assume that two researchers who don't know each other, and the world is large, there are many researchers, that may well happen, conduct some similar experiment, maybe in medical science or behavioral science, where you have two groups of people, the one gets some treatment, the other get another treatment, and one researcher finds a significant effect of some treatment, and that's an interesting discovery. But the other researcher really finds no effect, not even a non-significant one, he just finds no effect. Now, if they now send their findings to some different scientific journals, it may well be the case that also the editors of the journal don't only know the one experiment, they don't know both. And it's probably more likely that the article who finds a significant result finally gets published, and the experiment that does not find effect is not published. Maybe the researcher also predicts this and doesn't even send his article where he doesn't find an effect to any journal. But then, if only one of the articles gets published, our published scientific knowledge is kind of biased, because it more strongly suggests that there is an effect compared to the case that both of the articles would be published. Now, and a lot of people think that this is not just a hypothetical story, but that things like this systematically goes on in scientific research. Now, it can be even worse if people have very strong incentive to publish some results, maybe in order to get a permanent job at a university or to get more funding money. And and if the journal maybe has relatively lax standards. Because then he may also try actively to get results. So I mean, the worst case would be if he just falsifies his data. I mean, this is really bad. Unfortunately, it has happened sometimes, hopefully not much. But he could maybe also try out different regression specifications. So maybe add different control variables. And interestingly, if you try out a lot, you have a much higher chance to find some significant effect you want. So if you're interested, you can take a look at this link. This is actually my blog, and here I have run some simulation in R that shows you how by selecting control variables, you can really find systematically low p-values even if there is no true effect.